Good morning to everyone. Today we will be performing a test of concrete which is known as NDT test. The full form of NDT test is non-destructive test. What do we mean by non-destructive test? The first question should come to our mind that what do we mean by non-destructive test of concrete? Now, non-destructive tests of concrete are those tests which are carried out on an existing concrete structure without or partially damaging the concrete surface. Non-destructive tests are those tests, I repeat, which are carried out on any existing concrete structures. The concrete structures may be plain cement concrete, it may be reinforced cement concrete, and it can also be pre-stressed concrete, but without or partially damaging the concrete structures. If we perform the test, then those tests can be classified as non-destructive test. Now, some examples of non-destructive tests which are being carried out without damaging the concrete surfaces are rebound hammer test, ultrasonic pulse velocity test, rebar locator test. Another test, in my definition I have mentioned that partially it can be damaged. Now, concrete core cutter test is an example of non-destructive test which can be performed, but we have to partially damage the concrete surface while extracting the core of concrete. Now, today we are going to perform an experiment on one of the non-destructive tests, which is USPV test, known as ultrasonic pulse velocity test. Okay. It is one type of non-destructive test, and it has been stated according to IS 13311 part 1 of 1992 and has been recently amended in the year 2004 that ultrasonic pulse velocity test can be carried out to determine various properties of concrete. I repeat, ultrasonic pulse velocity test is a non-destructive test, and the code which governs it is Indian Standard 13311 part 1 of 1992, and it has been recently amended in the year 2004, and the test is being carried out to determine concrete's various properties. Properties in the sense we can determine the presence of cracks on the concrete, we can determine the presence of voids inside the concrete, we can also determine the homogeneity of concrete, and the various materials which the concrete has been constructed can be to some extent determine its density also. So, these properties can be ascertained with the help of USPV test. Now, why we need to understand why we are emphasizing on the fact that we are eager to do non-destructive test. First of all, the existing concrete structures, for example, if we take like what are name some concrete existing structures? Buildings, roads, some bridges, these are all existing concrete structures. Now, these concrete structures cannot be brought to the laboratory for its testing. For example, if we cannot bring a beam to the CTM machine for testing its compressive strength, neither a road nor a deck of a bridge can be brought under the CTM to test its strength or other properties. So, we have to take the help of non-destructive test to perform this property determination test. So, the existing concrete structures, we need to find the properties to know when to repair them or when to check its serviceability conditions, and also to some extent to determine the deterioration of the concrete structures. So, non-destructive test plays a very important part in our daily life while working with concrete structures. And non-destructive test, one advantage, major advantage is that while we are performing that test, that structure is not fully destroyed or demolished. For example, if we perform a cube test, then the cube cannot be reused. But if we are performing the non-destructive test on some existing concrete structures, for example, a bridge, a building or a culvert or roads, we can use it again. Some repairment has to be done, but the structure can be used. So, to check the durability or the serviceability or the repairing criteria, we need to perform the non-destructive test over this concrete structure on a regular basis. Okay? So, today our experiment is, as we have stated, ultrasonic pulse velocity test. Now, from the name we know that ultrasonic pulse means a wave, but this wave, ultrasonic pulse, is a complex wave. It is not readily available in nature. Unlike ultraviolet rays, infrared rays, or to some extent radio waves, these are readily available in nature. But this ultrasonic pulse have to be manufactured by accumulating 2 or 3 different types of waves. Now, this complex wave, the ultrasonic pulse, has been manufactured by combining majorly 3 waves. Those waves are surface waves, longitudinal waves and Rayleigh waves. So, the 3 waves, can you state what I have said? The 3 waves are surface waves, longitudinal waves and Rayleigh waves. These 3 waves combine and form a complex wave which is known as ultrasonic pulse. Okay. Now, USP, and there is another alphabet which is V. V stands for velocity. Now, we know that velocity is displacement per unit time. It is a vector quantity. Displacement in per unit time give us the value of velocity. Now, what velocity we are trying to find out? Is the concrete moving? Definitely not. Then we are trying to find out the velocity of the ultrasonic pulse at which it is traveling inside the concrete. The velocity of the ultrasonic pulse with which it is traveling inside the concrete material, may it be RCC, it can be pre-stressed, or it may be normal PCC. Okay? So, this is our ultrasonic pulse velocity testing machine. Now, this is a machine which is a very useful one, but it has got many parts inside. So, if we carefully look at the diagram which we have drawn, we can see that ultrasonic pulse velocity machine has got few components inside it. The first component is the pulse generator, from where the ultrasonic pulse is being generated by combining those waves. From the pulse generator, the pulse is being traveling to the transmitting transducers. Now, there are 2 different types of transducers. These are being stated as the transducers. One is the transmitting transducer, another one is the receiving transducer. The transmitting transducer major function is to emit the wave or the ultrasonic pulse, and the receiving transducer is receiving the pulse or the ultrasonic pulse. Now, if we carry our network diagram, we can see the transmitting transducer is transmitting the ultrasonic pulse, and it is traveling inside the concrete specimen until it reaches the receiving transducer fixed at another end of the same end. Then from the receiving transducer, the pulse is being traveling to the receiver amplifier. What is the work or the function of the amplifier? The amplifier amplifies the wave. Amplifies means modifies or converts the wave from frequency to time, which is required to determine the velocity of the wave. Now, the amplifier amplifies or converts the wave from frequency to its time unit. Now, the time taken by the wave to transmit from transmitting transducer to the receiving transducer is being recorded in the time measuring unit of the instrument. Now, from the time measuring unit, it is being displayed to the time display unit. One thing we have to keep in mind, that the display unit is displaying the time in microseconds. I repeat the network diagram. At first the pulse is being generated in the pulse generator. From there the pulse is being traveling to the transmitting transducer. From the transmitting transducer, the ultrasonic pulse is being emitted. Now, from the transmitting transducer, the ultrasonic pulse is traveling inside the concrete and going to the receiving transducer, where the wave is being received. Then from the receiving transducer, the wave is being transferred to the receiver amplifier. What is the function of the amplifier? I just told. Very good. Amplifier converts or transforms the wave from its frequency to time measuring unit. Now, the time then is being recorded in the time measuring unit, and from that it is being displayed to the displayed unit in microseconds. Okay. Now, this ultrasonic pulse velocity test has got three methods by which we can perform it. Those are direct method, semi-direct method and indirect method. Now, if we carefully looking at the network diagram which is being displayed on the board, when the transmitting transducer are located on the opposite sides of the concrete specimen, then that method is known as direct method. When the transmitting transducer is being located on the adjacent surfaces of the concrete specimen, it is known as semi-direct method. And when the transducers are located on the same face of the specimen, it is known as indirect method. So, these are the three methods by which a USPV test can be performed. Now, for determining the velocity, we said that we will be requiring two things. One is the displacement value, another one is the time. Now, the time is being displayed here in the USPV test in the time displaying unit, as we can see. Now, there has to be a displacement. The displacement in this term is called as the path length. What is the mean by path length? It is defined as the center to center distance between the two transducers. By two transducers I mean transmitting transducer and receiving transducer. So, the path length can be described as the center to center distance between the two transducers, which can be manually measured, and if we divide that by the time taken for the wave to transmit from transmitting transducer to receiving transducer, will give us the value of the velocity. The ultrasonic pulse velocity with which the ultrasonic pulse has been travelling inside the concrete surface from the transmitting transducer to the receiving transducer. Okay, clear to everyone? Yes, any questions? No. Okay, now as we can say that if the path length is considered to be constant, then we can say the velocity is inversely proportional to the time period. If the displacement or the path length is taken as constant in the three methods, then the time period for which the wave travels from transmitting transducer to the receiving transducer is inversely proportional to the velocity of the wave. Now, if we consider a concrete cube, we can say that if the concrete cube is being well compacted and is homogeneous enough, then there will be a very tough or a few voids inside it. Now, the wave, since we will find only one medium to travel, will travel at a faster rate in a well compacted and homogeneous concrete as compared to a less compacted and a void concrete. So, if in a homogeneous concrete or the concrete which has been well compacted, where the wave travels faster, there we will be receiving the velocity value at a higher pace as compared to the wave which has been traveling at a much slower velocity in a less compacted and a void concrete specimen. So, if the concrete finds a very dense medium, it will travel at a faster rate and the time taken for it to reach from the transmitting transducer to the receiving transducer will be less and the velocity value will be more. Whereas, in case of a void concrete or a less compacted concrete or a non-homogeneous concrete, the time taken by the wave to travel will be more and consequently the velocity value will be less. So, according to IS 13311 part 1 1992, which has been amended in the year 2004, it gives us a chart which determines the velocity value with the quality of concrete. It states that if the velocity of the wave is less than 3 km per second, the concrete can be considered as a doubtful concrete, which means that the concrete requires immediate repairment or it needs to be taken care immediate action. Now, if the velocity of the wave is in the range of 3 to 3.5 km per second, the concrete can be considered as of medium quality and it requires frequent testing. It may break down at any moment and it is giving us a warning sign. Now, if the velocity of the wave is being 3.5 to 4.5 km per second, the concrete is in good condition. And if the velocity is greater than 4.5 km per second, the concrete is in excellent condition. Okay. From these values, we can determine the condition of the concrete and whether it requires immediate requirement or not. Now, also we can find the modulus of elasticity value of the concrete according to IS 456 2000, which is a code of RCC and PCC. We can say that the modulus of elasticity of concrete can be considered with the grade of concrete related as modulus of elasticity value equals to 5000 root over FCK, where FCK denotes the characteristic compressive strength of concrete, and E is the modulus of elasticity value, which we require for designing our mechanics of structure problems. Remember, E into I we have, which we require. So we can also find out this from this test. Now if we look at that specimen, we will be performing today the specimen of a concrete cube. Now as we have stated, that USPV test can be performed by 3 different methods. What are the methods? Direct method, semi-direct method and indirect method. Now for performing the direct method, we need to transmit the 2 transducer on the opposite sides of the concrete specimen. If our concrete specimen is a concrete cube of weighing 150 mm per side, then for performing the direct specimen we have to place it on the 2 opposite sides, the path length being the center to center side distance between the 2 transmitters. Now if we perform the test by indirect method, we have to place it on the 2 adjacent sides. Now if we want to perform it by semi-direct method, we need to perform it on the 2 adjacent sides. Now for example, which do you think is more accurate method among these 3? Why? Because the wave will be getting the maximum chance to travel, its path length will be more. But where, for example, in this beam or in this column, where we are not getting a chance to perform the direct test because its ends are fixed, there we have to perform the semi-direct or indirect methods. Now the average can be considered as the average velocity by which the concrete travels. Okay. Now for performing the test, we require a gel which is stated as USPV gel. The main function of this gel is to prevent the air from getting inside the surface where it is to be tested and the transducer. It has to be void free. So we will be applying this gel on the transducers. Here the transducers, as you can hear, one is the transmitting transducer through which the wave is being emitted, we can hear the sound, and one is the receiving transducer which will be receiving. Now we have to apply the USPV gel on the concrete surface also, where we have to measure the value. Okay. Now as we can see, there is an observation table which we have done. From the observation table we have seen that USPV test, we have stated that serial number, path length, time taken and the velocity. But remember one thing, the velocity has to be determined in kilometer per second unit. Okay. Now if we are performing by direct method, we have to take the specimen on the 2 opposite sides. Now by keeping the specimen on the 2 opposite sides, we will be getting a value. Here the value comes as 60 microsecond. So our observation 1 will be the time taken is 60 microseconds. Now, what will be the path length in this case? As I have told you that this specimen is of 150 mm, therefore, the center to center distance is the path length, which is 150 mm. So, now dividing 150 mm by 16 seconds, we will be getting the velocity, but remember the velocity has to be in kilometer per second. So, we have to convert it. So, 1 mm is 10 to the power minus 6 kilometer, and 1 microsecond is equals to 10 to the power minus 6 seconds. So, please perform the calculations. What we are getting? 2.5 kilometer per second. This is our method of direct method by which the velocity has been adjourned as 2.5 kilometer per second. Now, if we perform the test by indirect method, we will be applying on the two adjacent sides, semi-direct. On the two adjacent sides, we will be getting a value of approximately 12 seconds. The path length being 75 plus 75 mm, it is considered to be roughly 150 mm. So, what will be our values in this velocity method? Calculator. Okay, it comes as 12.5 kilometer per seconds. Now, if we want to perform it by indirect method, we have to fix it on the same surface. So, if we are performing the test on the same concrete surface, we are getting a velocity value of 36 microseconds. 36 microseconds. The path travel we can measure is the center to center distance between the two adjacent points, which is roughly 130 mm, which is roughly 130 mm. So, what will be our velocity in this case? Okay, our velocity in this case is approximately 3.67 kilometer per second. So, from these values we can conclude from our chart codal provision which is given that from direct method, which is as 7.5 kilometer per second, which is above 4.5, so the concrete condition is excellent condition. But from our semi-direct and indirect condition, we have obtained the values between 4 and 4.5 kilometer per second, which states that the condition of the concrete is good. So, by these methods we can check regularly and find out whether the concrete surface need immediate treatment and at what pace the concrete is deteriorating. We all know due to the weathering effect, the surface of the concrete deteriorates and the concrete weakens, and it requires treatment as time goes on. So, by this method of non-destructive test, we can determine the quality parameters of concrete and the frequency in which whether it requires immediate treatment, or the condition is in good state, or it requires to be continuously monitored. Now, one thing which we must tell, that there are some limitations of this test. The limitations being, the surface of the concrete should be smooth enough for the wave to transmit and receive from the surface of the concrete. Next, the concrete should be in dry condition, because moisture contains on the inside as well as outside surface, as well as the type of aggregate and cement we are using, and also the age of concrete plays a significant role in the quality parameters. So, this limitations has to be kept in mind before performing the experiments, and direct method is considered as very accurate method of USPV test. Otherwise, if it can be performed, we need to perform the semi direct and indirect methods and average their results, and hence make an conclusion. So, in quality control department, this test plays a very important role in determining the condition of the concrete which is at present. So, thank you for this class, may you like it. Everyone, today our next test is rebound hammer test, which is also a non-destructive test. So, in our previous video we have told that what do we mean by NDT test? Please, what do we mean by NDT test?
No, it is a non-destructive test. When we measure in any existing structure to determining the concrete quality which we want to know, like cracks, specific gravity.
Hold on. So, non-destructive test, as she rightly said, that it is a test which is being performed on hardened and existing concrete structures without or partially damaging the concrete surface. So, the test of concrete which is being performed without or partially damaging the concrete surface are considered as NDT, or popularly known as non-destructive test of concrete. So, some of the examples of non-destructive tests are rebound hammer test, rebar locator test, ultrasonic pulse velocity test, and concrete core cutter test. So, today we are going to deal with a major non-destructive test which is known as rebound hammer test. Now, the rebound hammer test is being governed according to IS 13311 part 2 1992, which has been recently amendment in the year 2004. So, according to that code, rebound hammer can be used to determine the existing compressive strength of the concrete. We all know that for design purpose, the compressive strength of concrete plays a very important role. So, to determine the existing compressive strength, we need to perform a rebound hammer test. Now, this rebound hammer was being invented by a Swiss engineer, Ernest Smith, in the year 1948. The rebound hammer is also popularly known as Smith's rebound hammer or Smith's hammer, according to our popular scientist cum engineer Ernest Smith. So, if we carefully look at this rebound hammer, it approximately weighs 1.8 kgs. the weight of this rebound hammer is approximately 1800 grams or 1.8 kg. Now, this rebound hammer is a spring mass system. The construction of this rebound hammer consists of mainly two parts. This part is known as the body and this part is known as the plunger. The plunger is attached to the body by means of a spring. Hence, it can be rightly described as a spring mass system. Again, I am repeating, the rebound hammer consists of a spring mass system. The mass being the body of the rebound hammer, this one, and it is being attached to the plunger by means of a spring. On the rebound hammer, we can see a graduated scale is being given which indicates the rebound number. Now, on the other side, there is a graphical representation of compressive strength in the ordinate and rebound number in the abscissa with a lock button where we can lock the plunger. Now, the rebound hammer works on the principle of Newton's law, which states that to every equal and opposite reaction for every action force. For every action, there is an equal and opposite reaction. How does it work here? We can rightly see that if we press the rebound hammer against a concreting surface, then the plunger gets into the body due to the recoilation of the spring. The recoilation, the displacement of the spring is being indicated by a number which is popularly known as rebound number. While we are applying a force against the concrete surface whose compressive strength is to be determined, the concrete surface also exerts an equal and opposite reaction force on the rebound hammer. In that case, the plunger of the rebound hammer pushes the spring inside, due to which the spring recoils and the lateral displacement of the spring can be recorded in terms of a number which is known as rebound number. It is absolutely a dimensionless parameter, it is just a number. From the rebound number, we can see there is a graphical representation of compressive strength in the y axis or the abscissa and the rebound number in the x axis. The rebound number which we are getting will be plotted against various angle of inclination with which the rebound hammer is being struck. Now, for your kind information, may I tell you that the angle of inclination is the angle which the rebound hammer is being struck against the concrete surface. The angle which the concrete surface is making with the rebound hammer is known as angle of rebound or angle of inclination of the rebound hammer. For example, it can be done in a 0 degree angle or a plus minus 45 degree angle or a 90 degree angle. The rebound hammer can be tested in horizontal direction, in vertical direction, as well as in an inclined position. So, to perform the rebound hammer, we have to first ascertain the angle with which the rebound hammer is making with the concrete surface. Now, for example, if the concrete surface makes an angle of 90 degree, we will be corresponding the angle with 90 degree value. Now, if we are getting a value, if we are demonstrating, if we are getting a value until a rebound number hammer strikes. Now, this is, you can see, it is an impact type of energy which is being provided on the concrete surface. Now, due to the impact energy, the spring is being recoiled and we are getting a value which is roughly stated as what? 20. Now for example, if we are giving a 20 value on the rebound number and our angle of inclination with the concrete surface was 90 degree. So from 20 value and 90 degree we will be getting a compressive strength in the ordinate. The corresponding 20 rebound number which we have got and the angle of the slope as 90 degree, we will be getting a value of approximately in that zone. If we carefully observe that for 20 rebound hammer we will be getting a value close to approximately 300. Now the rebound hammer gives the value in the graphical representation in kg per centimeter square, but our standard value is being measured in Newton per millimeter square or megapascal. So we need to convert the values from kg per centimeter square to Newton per millimeter square and hence determine the existing concrete strength, compressive strength of the concrete or the grade with which the concrete has been prepared. Now can anyone come and perform the test? Come perform the test on the specimen. For example, this we are taking as phase 1 and the rebound value which we are getting is 28. So phase 1 our rebound value is 28 and our angle was 90 degree. Next on phase 2 you can also perform one on the at an angle. So our angle was in this case was 45 degree. So in this case our rebound value was low to some extent and it came as 18 and our angle of rebound was 45 degree. So by this method we can also determine the compressive strength which we will be getting in the graphical representation and easily determine the grade of concrete. What is the compressive strength for rebound number of 28 which we have got? Here is the value of 28 at an angle of 90 degree and our compressive strength comes as 280 kg per centimeter square. Our compressive strength comes as 280 kg per centimeter square. Now from that we can conclude that the grade of concrete is approximately M25. From the value we can conclude the grade of concrete as M25. So I hope all of you have understood the experiment.
Yes, sir.
Is there any doubt? Any questions? Thank you.